Okay, this is a walkthrough of the OCR GCSE Computer Science Paper 1, which is the Computer Systems Theory paper. I'm going to try and do this in 45 minutes or less, so let's get started. The paper is 90 minutes and there are 80 marks available, so that's roughly 1 minute per mark or 1 mark per minute. In many cases there are some tick box questions which are much quicker than a minute to answer. And all the gained time, I would suggest that you spend on the quality of written communication question, which is an essay question present in every GCSE paper 1. The marks for each question are shown in brackets, and the essay question that I just referenced, the QER answer or question, will be marked with an asterisk. It's usually worth 8 marks, and I'll make that very clear when we come to it. So let's get started. Okay, the first question is a nice, easy intro. They usually do this on the OCR paper. They give you a nice settler on the first 1 or 2 pages. So computers represent data in binary form. Tick 1 box to identify the statement about binary that is true. So this is very much, can you eliminate which ones are incorrect and go for which one is correct? Binary digits can only be the values 0, 1 and 2. Now, if you've had any kind of teaching about binary, you'll know that binary is just 0s and 1s. Most commonly, you'll see the power button on a computer looking something like this. And that's not a coincidence. It's a 0 and a 1 merged together. So this one is incorrect, so it's not this one. The leftmost bit of a binary integer has the smallest value. That's not true. The leftmost bit of any binary integer is what we call the most significant bit. For example, if I was trying to make the number 255 in binary, hopefully you should already know that 8 ones would equate to 255. That's because the place values are 128, 64, 32, 16, 8, 4, 2 and 1. And if you add them all together, that will give you 255. The biggest number of all of those is the one on the left. So that second statement is also incorrect. Binary is used because computers are made of switches that can only be on or off. Now that's a possibility. Let's just check the fourth one. The smallest whole number that can be stored in 8 bits is the number 1. Well, again, if I go to my notepad, if I put 8 zeros, because the question references 8 bits, that equals 0, and 0 is less than 1. So therefore the fourth option is also incorrect, which leaves us with a big tick in option number 3. So nice easy question to begin with. Complete the table to write the missing denary, 8-bit binary or hexadecimal values. Okay, we're looking for a denary answer first. Denary is the same as we use in our normal number system. So any number from 0 to 100, for example, would certainly count as a denary answer, or a denary number. And the clues that we're given are 7 for hexadecimal, which is actually a bit of a trick because there's only one value there. Or we've got an 8-bit binary number, which is 5 zeros followed by 3 ones. So let's use that if we can to help ourselves out. 5 zeros followed by 3 ones. The placeholder values for those are 4, 2 and 1. If we add 4, 2 and 1 together, that gives us 7, which does correspond with the hexadecimal number there, but we're looking for the denary answer. So 7 would go in the denary answer box. Okay, second question in this series of 4. We've got the denary number 49, the hexadecimal number 3 or 1. Notice I didn't say 31. So let's see what we can do with this. We've got 2 options. We can represent 49 in binary by, let me just use those placeholder values again, 128, 64, 32, 16, 8, 4, 2 and 1. Does 128 go into 49? No, it doesn't. Does 64 go into 49? No. Does 32? Yes, it does. And that would leave us with a remainder of 17. Does 16 go into 17? Yes, it does. That would leave us with a remainder of 1. Does 8 go into 1? No. Does 4 go into 1? No. 2 doesn't go into 1, but 1 does go into 1. So that would leave us with an 8-bit binary number of 00110001. Okay, I'm confident that's the correct answer, so I'm going to commit that. Okay, and let's just quickly check hexadecimal 3-1. Okay, I'm going to use a different colour for hexadecimal. I'm going to use green. 3-1 is not 31. Okay, when we're talking about hexadecimal, what we've got is a column that's worth multiplied by 16 and a column that's worth multiplied by 1. 1 times 1 is easy, that's 1. 3 times 16, that's 48. If I add 48 and 1 together, that gives us 49. 49 was our denary clue. Let's just check our binary number again. 32 plus 16 is 48, plus 1 is 49. So we can be extremely confident that this is the correct answer. Okay, third row. We're given a binary number again. So let me go to my cheap and cheerful fortnight notepad. 0110, 0110. Okay, nice and easy. 0110, 0110. And remember, the placeholder values above each of these just double every time you go to the left. 128 being the most significant. Now in this case, 128 isn't significant. We've got 64 plus 32 is 96. Plus 4 is 100. Plus 2 is 102. Okay, and I'm fairly sure that we can commit that as our answer. We can check the hexadecimal method if we want to. So 6 times 16 is 96. 6 times 1, again just using the same method as before, add them together, 102. Okay, so again we can be sure that that's the correct answer. And finally, we've got 244 as a denary number, and we've got a binary number which represents 244, and we're being asked to provide an answer that's in hexadecimal. Now, 2 ways to go about this. My preferred way to do this is to, let's do this in red, 244 divided by 16. Okay, how many times does 16 go into 244? Well, 10 times 16 is 160. Okay, so it's not 10. What about 5 times 16? 5 times 16 is 80. If I added those two together, that gives me 240. Okay, so that's interesting. 15 times 16 is 240. That means we've got a remainder of 4 to find. Now again, if we use that column method again, the left-hand side multiplied by 16, the right-hand side multiplied by 1. 15 could go there, and we've got 4 times 1 as the remainder. We're not quite finished because 15 isn't a hexadecimal value. The way that hexadecimal works, and I recommend anybody do this when they get into their exam and they see this type of question. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now 10 is a digit made up of 2 characters. And in hexadecimal, we only want to use 1 character to represent a number. So what we do is we change 10 to capital A. 11 will be represented by capital B, 12 by capital C, 13, you've probably worked out the pattern by now, 14 would be E, and 15 would be F. So what we do is 15 here, we change to F, and 4 we leave as it is. So the answer here would be F4. Okay, now I'm currently over my 5 minutes, I know, and this is only 5 marks available, but I am going to try and speed up now once we've got through the first couple of questions. Okay, let's fold the paper in half and see if I can zoom in a little bit. There we go. Okay, so tick 1 box to identify the largest file size. 2 million bytes, otherwise known as 2 megabytes. 2,300 kilobytes, otherwise known as 2.3 megabytes. What we're trying to do here is use the same unit of measurement, and therefore that the number that will tell us which is the bigger. 200 megabytes, that doesn't need converting. We can just copy that, 200 megabytes, because it's the same unit size. And 0.1 gigabytes. So we need to make that. What do we need to do? 0.1 gigabytes would be 100 megabytes. And the reason it would be 100 megabytes is because there are 1,000 megabytes in a gigabyte. This is not a gigabyte, it's a tenth of a gigabyte, so therefore it'll be a tenth of 1,000, so 100 megabytes. So the biggest one, 200 megabytes, so a big tick in the third box. Tick 2 boxes to identify the two file sizes that are equal to each other. 4.5 million bytes, so same method as we just used on the previous question, that'll be 4.5 megabytes. Mega means million. 450 kilobytes. Okay, that's going to be 0.45 megabytes for the same reason as up here. If we multiply this by 1,000, that's going to give us, well, no, that's going to be way too big. What we're interested in is what this is relative to a megabyte. Okay, this is just under half a megabyte because there are 1,000 kilobytes in a megabyte. So just under half a megabyte, 0.45, that looks correct. We've got this answer here, doesn't need converting because it's already in megabytes, so let's just copy that down and we can already see where our answer is going to come from because we've got two here that match. And let's just check 0.45 gigabytes. Now gigabytes are bigger than megabytes. There are 1,000 megabytes in a gigabyte. So this is going to be much bigger. This is going to be 450 megabytes. Because again, it's just under half a gigabyte. There are 1,000 megabytes in a gigabyte. Simple maths. It's much bigger. So these two are the same. So the question says tick 2 boxes to identify. So 1 and 3. Easy. Okay, question here about binary addition, adding together two 8-bit binary numbers. Show all your working. Now, this is really important. When it says show all your working, it's because there's usually more than one mark available. And if you get the answer wrong, you may get a mark for your method. So this is really simple. 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 1 again is 1. Same again. And now we get to 1 plus 1. Now, 1 plus 1 in maths is 2. But 2 in computing is written 1, 0. Now, we can't put 1, 0 here because we don't have room. So what we do is we put 0 here and we carry our 1 over to the column to the left. That then means that we've got 1 plus 0 plus 1. Again, 2. So we do the same thing. 0 here, carry the 1. Same again. 1 plus 0 plus 1 is 2. So 0 in the answer row and 1 is carried over to the next column. 0 plus 1 plus 1 is 2 again. So 0 goes here and 1 gets carried over. Now we've got a small problem here. We've got what we call an overflow bit. An overflow is when there's too many bits in our answer compared to how many bits are available for our storage. And in this case, the correct answer will be 4 zeros followed by 4 ones. This red overflow bit, I'm just going to put brackets around it to show the examiner that I understand that's an overflow. I could even put overflow if I really wanted to show off. Okay. It's also in red and they mark anything you put in black. I wouldn't recommend you do this in the exam. You're only allowed to take in black pens usually. I'm going to guess that the mark scheme says 1 mark for the method, 1 mark for the answer. Okay, so plus 1, plus 1. Okay, and identify the binary shift that has been applied to the 8-bit binary number 101140 to get the result 1 followed by 7 zeros. Okay, interesting. We've got some 1s here at the start, so I'm already thinking that the binary shift is going to be to the left. Okay, the binary shift is to the left. Now we've got 1 followed by 4 zeros. This is 1 followed by 7 zeros, so I'm going to say it's a left shift. 1, 2, 3 places. Okay, you'll notice again there's 2 marks. I'm going to say plus 1 for saying to the left, plus 1 for saying 3 places. Okay, and that's the first double page of 2023 paper 1 answered, and I'm 100% confident that we've just got full marks. So not a bad start. 5, 6, 7, 8, 9, 10, 11. 11 out of 11. Right, questions that aren't so popular now. Protocols. I don't know why they're not so popular because there are only about 7 protocols that we have to know, and many of them are self-eliminating because they don't match up with what we're looking for. Okay, so complete the table by identifying the most appropriate protocol for each of the tasks the student is performing. Requesting to view a news web page from a web server. So you should already know that when you're using the internet, you've probably seen HTTP in the address bar. That's the protocol that you're using to view a web page. You may sometimes see HTTPS. The only difference is S means secure, which means the web page is encrypted. Typically, HTTPS is what you'll see when you log onto your bank. HTTP might be on something like, I don't know, BBC Sport, for example, because it doesn't need to be secure. All you're doing is viewing perhaps the football results. However, I realise already I'm incorrect. If you go on BBC Sport, many websites now are HTTPS, just as standard. So for this answer, I'm going to put HTTP. You would also be correct if you put HTTPS, but I'm going to save that because I can see the next question already might require that. So entering a username and password to access their bank account. I already just said that HTTPS is usually something you'll see when you're doing something like online banking. So I'm going to commit to that without too much thought, HTTPS. Okay. Downloading a text document from a web server. Now, you could use HTTP or HTTPS, because if you're downloading a text document from a web server, you're likely using a website to access that web server. You usually don't have direct access to a web server. You'll be downloading from a website. So HTTP would be accepted. HTTPS would be accepted. But I'm going to show off that I know that something called file transfer protocol exists. Okay, and all we need to do is take the first 3 or the first letter of the 3 words to create the FTP acronym. And finally, checking for new emails in their inbox. Now, there's a few email associated protocols. There's SMTP, Simple Mail Transfer Protocol. That's for sending emails. There's also IMAP, which is Instant Message Access Protocol or Instant Message Across Protocol. And POP, which is Post Office Protocol. Either of the last 2 would be acceptable. So I'm going to go with IMAP, but you could also say POP as well. Okay. Some protocols have layers. Give 2 reasons why protocols have layers. Now, if you think about anything that you have in your own life which has layers to it, or compartments or sections, why do we have things contained in layers or sections or compartments? Well, usually it's to separate things, isn't it? So I'm going to say separates tasks so that they can be worked on separately. Okay. Now, if ever I'm trying to concentrate, I don't do well concentrating with too many people around because I'm quite easily distracted. I'm always kind of people watching and pay attention to what other people are doing. So when I'm concentrating on something, I like to do it independently, i.e. on my own. So I'm going to say, same thing here, each layer is independent. E.g. layers are not reliant on each other. Okay, or other layers. And I'm 90% confident that I'll get both marks for those responses. Probably one of the more difficult questions on the paper because protocols isn't usually something that we give a lot of attention. But this idea of layers in particular, even less so. So those 2 marks are going to be quite hard to get for the majority of students. Okay, 2BI. One characteristic of a LAN is that they are set up over a small geographical area. Hopefully your teachers have already taught you the difference between LAN and WAN, local area network and wide area networks. Give one other characteristic of a LAN. So we're not allowed to say small geographical area because that's already been said in the question. What else would a LAN have that a WAN doesn't? Okay, well, when you use a WAN, typically you're going to use something like BT or Virgin Media cables. If you've got two schools that are a mile apart and they want to connect to each other, you're not going to run a cable between the two schools across the street or maybe over some fencing or over some houses, because that's going to be very impractical, unsightly, and potentially also a bit of a hazard. So what you would do is you would use somebody else's cables, typically BT, Virgin Media, any of those companies. Now, when you've got a LAN, you don't need to do that. So I'm going to say my answer will be no external or third-party cables or hardware required. Simple. You could say something similar to that, like uses their own cables or something like that. That would also be perfectly fine. Okay. Describe the benefits of the student changing their home LAN to include wireless connections. So the implication there is that currently their LAN does not have wireless, so they must have wires everywhere. They go to the bathroom, take their phone with them, their phone must be connected via a wire. Quite a strange situation, I know, very unlikely. But what would the benefit be of the student including wireless connections? Okay, well, the first thing is convenience of being able to move around. Okay, if you need to go to the bathroom and you want to take your phone with you, first of all, you're disgusting. I hope you wash your hands and your device, but many people do it. So let's say convenience, and we're going to elaborate on that. Ability to move around the house and maintain a connection. Okay. Now, in my flat, I've got a sticker on my fridge which is BT wireless QR code. And if someone comes around and they want to use my Wi-Fi, I just say to them, "Yep, stickers on the fridge. If you snap it with your camera, you'll connect to the Wi-Fi pretty much instantly." So I'm going to say, easier for guests to quickly connect to the network. And I'm just going to say in brackets, e.g. scanning a QR code to connect. Don't know why I wrote that so close to the edge, but there we go. And I'm confident that will get me all 4 marks. Same for you if this kind of question comes up. But you could also say it allows more devices to connect, because as I just referenced, mobile phones don't have Ethernet ports, so you can't use wires to connect mobile phones anyway. If you went to someone's house and all they had was wired connection, you'd be using your data and not their Wi-Fi. Okay, state 2 drawbacks of changing their home LAN to include wireless. So these are the benefits. Now we need some drawbacks. I've long suspected that my neighbour tries to connect to my Wi-Fi, especially when it's performing very badly. So I'm going to say increased risk of security issues. So like somebody else hacking or connecting. So I'm going to say hacking or unauthorized connections. Okay. And wireless is also less stable than wired. If ever we have thunder and lightning, my Wi-Fi typically will go down for about 5 minutes. So I'm going to say less stable connection because it's more prone, it's more vulnerable to interference. And if you just want to make sure the examiner knows what you're talking about, say e.g. thunder, lightning, and in some cases very, very bad weather, like rain. If you're watching something on Sky Digital, you might notice that the rain can sometimes knock out your program temporarily. Okay, so another 4, 6, 7, 8, 9, 13 marks in the bag. So I reckon we're already 24 out of 24. Okay, I like these questions because they're kind of multiple choice. You've got some options in the box here. You just have to find the correct one. So my suggestion is read the sentence and then choose the one that makes the most sense. A character set stores something of the characters that the computer can represent. Something of the characters. Okay, so it's going to either be, in my opinion, all, one, or some. I don't think similar would work. So all, one, or some. It's not going to be one because there's S's at the end of each word indicating plural. So it's going to be all or some. And I don't get why a character set would store some of the characters that the computer can represent, unless it was a particularly limited one. So I'm going to go with all. Let's be positive. Each character is given a something binary code. A something binary code. Now we used all, so let's put a line through that. Could be different, a different binary code. Identical binary code, possible, less likely though. Each character is given a 1 binary code. No, that won't work. Repeated binary code, doubt it. Similar binary code, possible. We've said identical and different already. Some, no, and unique, very possible. I like the look of different or unique because I think each character would have a unique or a different binary code. So let's go with unique there. Unique New York. Anchorman reference there. Lowercase and uppercase letters in a character set are given something binary codes. Something binary codes. Now that could be unique again, couldn't it? Lowercase and uppercase letters in a character set are given unique binary codes. But we've used unique already, so let's use a different word. Different? Similar? It's going to be one of those two, isn't it? So let's say different, because I think it would be slightly odd if they were similar binary codes. One example of a character set is ASCII. This character set uses something bits for each character. Now, ASCII technically uses 7 bits. But if you look up here, there is no option for 7 bits. There is no 7. Now, there's something called extended ASCII, which uses 8 bits. So let's assume that that's what they're talking about. And in fact, if you look in the OCR spec, they do very clearly say that when they refer to ASCII, you can assume automatically that they're referring to 8-bit ASCII. So I'm being a bit pedantic there. If the code value for the character F is 70, then the code value for the character L is... Okay, some simple maths here. F is 70. L is down here. What have we got in between? G, H, I, J, K. So 71, 72, 73, 74. I believe it's going to be 75. Let me just check that again. F, G, H, I, J, K, L. 71, 72, 73. Oh, I made a mistake, haven't I? Silly Billy. 74, 75. It'll be 76. My bad, sorry. I didn't line them up very well. So F is 70, G is 71, H is 72, I is 73, J 74, K 75, L 76. Good job, I doubted myself for a second there. Always check. Like I always say, go with your gut, unless you know your gut's wrong, and then check. But what you don't want to do is overthink something, because that's when you get in a bit of a time-wasting scenario and you're still not sure of what you put as the answer. Okay, nice easy question here. The metadata states that the image is 3 pixels wide by 4 pixels high. Data in the blah, 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 that's kind of irrelevant at the moment. It's referring to the next question. State what is meant by metadata in an image file. Metadata basically is data about data. Okay, so if I took a photo, for example, one of the bits of metadata that it would store is the geolocation of where I took the photo. It would also stamp the date and time. So it's data about the data that you've saved. So my answer is going to be data about data. Don't need to complicate it. Keep it simple. So we probably got 5 for that one. we've definitely got 1 for that one. Another 6 marks in the bank. I think that's 30 out of 30 so far. Let's look at this next question. The binary data stored for the image is given. Oh, lots of zeros and ones, so we're probably going to have to chop this up in a minute. A grid is given for the image and each square is 1 pixel. Write the name of the colour in each square that the pixel will show for this image. Now for this I actually need to unfold the paper because there's a clue on the previous page. Binary numbers can also represent images. The table shows the colours that are used in an image and the binary value for each colour. Red is 4 zeros, green is 2 zeros with 1 0, blue 1 3 zeros, purple 0 1 1 0. So all we've got to do is essentially chop this up into blocks of 4. 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4. You don't want to keep hearing me saying that. Okay, and then read from the key. So 0 0 0 0 is red. Let me just check. The data in the file starts in the top left hand corner of the image and goes from left to right, top to bottom. Okay, thank you. So 4 zeros is red, so that's going to be red. 4 zeros again, red, and then 0 1 1 0, which is purple. Okay, so let's put purple there. Okay, so we've done red, we've done red, we've done purple. We've now got 1 followed by 3 zeros, which here is blue. And it said it goes left to right, top to bottom. So blue, thank you, 0 0 1 0, which is green. Thank you. 1 0 0 0, that's blue again. And we've used all these numbers already. So 0 1 1 0 is purple. Thank you. 0 1 1 0, repeating. And again, purple, 3 in a row. 4 zeros, I believe that was red. Thank you. 0 0 1 0. What did we say that was? That's green. Thank you. And 1 0 0 we said was blue. So nice easy question, that one, if you've got a little bit of logic about you. Oh, sorry, I realise you may not have seen everything I was doing there. So there we go, sorry. I chopped up the question into blocks of 4 and then used those numbers to correspond with the numbers over here in the key. Really, really simple. Didn't realise you couldn't see everything there. A colour depth of 4 is used. This means 4 bits are used to store the colour for each pixel. State the maximum number of different colours that can be represented in 4 bits. This is really easy. It's 2 to the power of n. And n in this case is 4. So it's 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And I'm going to put a box around it just in case they're not sure what my final answer is. The colour depth is increased to 2 bytes. Now remember, a byte is 8 bits. So this is now 16 bits. 2 bytes. State 2 effects that this change can have on the image. So basically you've got more bits available to store information about the image. So what this immediately means is that the quality of the image, maybe that's the resolution, for example, maybe it's the colour depth, but the quality of the image is improved or increased or refined or whatever you want to say, but I'd say improved or increased. But also, so will the file size, because there's now more data to store. So the file size will increase too. Now you'd also be able to say that because of that, more storage space is required. And you'd also be able to say, if you needed another one, number of available colours increases. So the colour range is now bigger. All right, the same way that if you earn more money, you have more options. If you've got more data, then more colours are available to you. So again, another 2, 3, 5. I think we're on 35 out of 35 now, very confident. What's this question saying? A student has a text document and an image file that need to be compressed separately. So compression is where we take something big and we make it smaller. The student needs to reduce the file size of both of these files as much as possible. Identify the most suitable type of compression for the text document. Now, text documents, remember, cannot be compressed or should not be compressed with lossy compression, because lossy will permanently delete some data. And when you permanently delete data from a text file, you may change the meaning of a word. If you had a word like count, for example, you have to be very careful what you deleted from that word, because you'd very quickly change the meaning of it and potentially offend somebody. Okay, so type of compression would not be lossy. For this one, it would have to be lossless. And my justification for that, no data will be permanently, they usually like it when you say permanently because it shows that you understand that it's not recoverable, removed. So no data will be permanently removed, okay? Which means file can be reconstructed back to its original contents. Okay. Identify the most suitable type of compression for an image file. We've already used lossless, so it would make sense that this one would be lossy. Now, lossy works with images because even though data is removed permanently, it might be something like a few colours are removed, so there's less colours available. The picture will still be clear, it just won't be as detailed as it would have been previously. Perhaps the quality is slightly lower. Okay, so for this one, it will reduce the file size a lot more, first of all, but the image will only suffer a small quality decrease. I think that would be enough. Usually humans would not notice this. Okay, so 3, another 6 marks in the bank. Thank you very much. Right, another tick box question. We like these because we can get through these quicker. I realise I'm approaching 40 minutes already, so I'm going to struggle to do this in under 45, which was my aim. Tick 1 or more boxes on each row to identify all of the methods that can help to prevent each threat. So what is it that we use that counteracts spyware? Well, the obvious one is anti-malware, because spyware is a form of malware. You could possibly also say firewall, but I'm going to use a little tick for that one. Big tick for this one because you'd have to say anti-malware. You could also say firewall, but if you don't say it, you'd still get it correct. This one is more correct. This one is kind of correct. You can tick both of them. If you're only ticking one, it would need to be this one because this one is less significant. Brute force attacks. Now, we usually talk about content delivery networks here, CDNs like Cloudflare, but that's not an option up here. So the only option really we can go with, anti-malware doesn't help against brute force attacks. Penetration testing, it can help, so I'm going to put a little tick there. Encryption, nothing to do with brute force attacks, but firewalls will monitor the incoming and outgoing traffic, so I'm going to put a big tick in firewall. Data interception, so when somebody steals your data. Malware, it's not a form of malware, it's social engineering, so anti-malware won't help us. Neither will penetration testing, but encryption will, because remember, encryption doesn't stop somebody stealing your data, it stops somebody from being able to read or use your data should they steal it. Okay, so they can steal it, but they won't be able to use it. Real life example or analogy, it's like when banks put ink in their ATM machines and you see these people on big diggers pulling ATMs out of the wall. Usually if ATMs are disrupted, the ink will be sprayed all over the notes so that the notes are useless. Doesn't stop them stealing the money, but it certainly stops them spending it. And I'm not going to talk about firewall for that one because data interception, it's just encryption that we would use. And then finally, SQL injection. That's where people insert malicious code into SQL databases, usually via web forms. So, you know, enter your postcode. If you know SQL, you can enter an SQL instruction and potentially delete a table or some data from a table. So the way we would stop that, anti-malware, no. Penetration testing, yes. And there's a small possibility you could also say firewall, but I wouldn't. I'd just go with the big ticks on each of these. Okay, name and describe one threat to a computer system that is not given in question 4A. So I talked about content delivery networks, which were not an option for the method of prevention. So we could go with like a DDoS attack. So DDoS would be one example, but I'm going to go with something much simpler, shoulder surfing. You could also say social engineering, you know, where you trick people into giving you their data. So shoulder surfing, which is where you watch someone, your mark, your victim, enter their password. It's called shoulder surfing because usually it's from behind, but we don't necessarily need to say that. And using it without their consent or knowledge to gain access. Okay. Now, I went into detail there because it's worth 3 marks. 1 for stating and 2 for explaining. So describing and explaining, try and go to as much detail as you can if you can see 3 marks available. Okay, I'm going to need to get a move on because I'm struggling to stay within my time limit here. An artist has a computer that they use to create images. Their computer has both hardware and software. The hardware includes primary and secondary storage. Explain why a computer needs both. Okay, really simple question to answer because primary is about storing what you're currently doing. Okay, so primary stores current activity. Now activity probably won't get me the marks, so I'm going to say instructions. Okay. And a 2-mark question, so secondary stores long-term data / files. So anything that you want to access over and over again, that needs to be saved in secondary storage. Quite a simple one, that one. Not an issue. You could also say in case of power failure or power off, but you probably don't need to go that far. Give one example of a secondary storage device that the artist's computer will have and an example of the data that will be stored on it. Basically, do you know your different types of storage device? I don't think there's a wrong answer for this one. I think you could say optical, I think you could say magnetic, I think you could say solid state, but they're an artist, so they probably work independently and sometimes need to send people some of their work. Now they might want to do that on a CD or optical drive. They may also do it on a USB flash drive or a memory card, but I think for this one there's many answers you could put that would be correct. And an example of the data, let's just say images of their work. So that might just be photos they've taken, for example, of their work that they want to share with potential clients. The computer has virtual memory, VM. The table has 4 statements about VM. Not all of them are correct. Tick the true column for the ones that are correct and rewrite any incorrect or false statements. So virtual memory is where you run out of memory in a computer. The RAM is basically fully used. So what the computer can do is use a small area of secondary storage to act as RAM. It's good in the short term, but the negative is that secondary storage is a lot slower than primary storage. So you'll notice it in the form of lag on your device, usually for a minute or 2. So I've already said a section of primary storage is partitioned to act as virtual memory. Well, I said secondary storage, didn't I? So I'm going to say primary arrow secondary, because I can't be bothered to rewrite the entire statement. Primary was incorrect. We need to change it to secondary. Okay, data from ROM is transferred into the VM. No, it's the other way around, if anything, isn't it? So I'm going to say RAM into VM. Oops. What have I done there? VM. There we go. So ROM is incorrect. It's RAM to VM. VM is needed when RAM is full or nearly full. Well, that was my description a minute ago, so that sounds correct. And data from VM is transferred back to secondary storage when needed. Well, secondary storage is when it's short-term needed, so it sounds like this is more long-term. So it's not going to be secondary storage. It's going to be RAM. Okay, so secondary storage is wrong. That should be RAM. Apologies for my note form, but we're short on time now, and I'm trying to complete this. The computer has an operating system and utility software. State the need for utility software. Basically, helps the computer run smoothly. Now that I might be doing things like tidying up, what we might call housekeeping actions. It can also help identify problems and fix problems with the computer system as well. But I'm just going to say helps the computer run smoothly by performing cleanup tasks. Now, that might be too much info for a 1-mark question, but I don't see that's a bad thing. The artist uploads images to be... We're still on the artist, blimey. The artist uploads images to be displayed on a website. This is a client-server relationship. Identify the computer that is acting as the client in this scenario. So a client-server relationship. Let's go back to my cheap and cheerful fortnight notepad. You'd have your server in the middle, your server with some racks. And your server will connect to many things. You might have a printer. You might have a router. Let's pretend it's got some aerials there. And you'll have some workstations. So there you go. There's a PC with a keyboard and a monitor. Maybe a printer. So I'm going to do a box with some paper coming out of it. Another workstation. And you get the idea. These are the clients. This is the server. These are the clients. Okay. So that's a client-server relationship. It's just the way the topology works. So in this case, the client computer is going to be, what's the question asking? Identify the computer as acting as the client in this scenario and justify your choice. So client computer will be the artist's computer. Sorry, took me a moment. What's my justification for that? Sends requests to the server. What else does it do? To upload or store files. Identify the computer that is acting as the server in this scenario and justify your choice. So in this case, that's going to be the server. And let's say images will be stored on the server. Same as when you're at school. Your files, you can usually access them in any computer, in any room. That's because they're not stored on the individual local computer, they're stored on a server, and the computer acts as a gateway to access those files. So images will be stored on the server. Do I need to say a bit more? Server, because it's a 3-mark question. Server receives / responds to client requests. I think that will be enough. If it's not enough, we should get 5 out of those 6. Okay. I think we've got a couple of questions left and we're approaching 15 minutes. So sorry, I'm longer than I said. I'm probably going to leave the essay question for now. The artist is working with a programmer on the development of a new piece of software. Software will allow users to edit images. But they're considering releasing it as open source rather than proprietary. Describe 2 benefits to the artist and the programmer of releasing the software as proprietary. Now, if I was an artist and made some music and I released that as proprietary music, that means you would have to pay me to listen to my music. Spotify is a bit different because Spotify, you pay a subscription fee, and Spotify would pay the artist X amount of money per stream or per 100 streams or whatever. So proprietary is basically about ownership of the work. And if you're the person that created it, it means, I can't spell, authors can earn money. I realise I've spelt wrongly there, sorry. Earn money from their creation by selling / charging a fee. You go to a restaurant, they don't give you food for free, do they? They charge you 1 for the ingredients that they paid for, and 2 for the effort, the work and the service that goes into cooking and serving your food. Okay, so authors can earn money. Also, no one can see or copy the code if we're talking about software. That's another benefit to the author or artist. Okay, the second benefit, silly, aren't I? I should have said no one can see, copy the code if it was software. So put a line through that. Don't scribble out your answers, by the way. Put 1 line through them, because if you don't follow up with a new answer, then markers can still give you credit if they can read it. Describe 1 benefit to the user of releasing the software as open source. This usually means that it's free, so no fee, no charge. Sorry, my handwriting's getting messier. User can also view the source code, view or change the source code. 2 marks, 2 points. We should be done. Okay, and then an essay question. What have we got after this? Let's just quickly check. Okay, let's answer the shorter question first really quickly, because I think we can get this all done inside 55 minutes. I'll try and be quicker on the next one. A car comes with many embedded systems, for example, parking sensors. So parking sensors, they've got basically distance detectors that detect how far away they are from something, and the beeping becomes more prominent and more regular the closer you get to the object. Identify 1 other embedded system that could be found in a car and explain why this is an embedded system. So my last car, one of the things I used to like about it is when it was getting dark, the headlights would also automatically come on. So I'm going to say auto headlights. You could also say auto windscreen wipers when it starts raining. Many of the windscreens nowadays have got sensors in them that detect rain, and the windscreen wipers will come on automatically. Okay, second part of the question is asking for an explanation. So we just need to say something like why it's an embedded system. So it's a smaller, what should we say? It's a smaller system inside a larger system, i.e. the car. Don't know if I've worded that correctly, but we might say that it has specific or limited functions. So basically it just has 1 or 2 jobs. Okay, 3 marks. Should I say anything else? I think that's it. Yeah, that should be enough. It would definitely get us at least 2 out of those 3. Okay, the essay question, I'm not going to have time to answer it, but I'll tell you how I would go about it. A shopping centre has a security system that includes CCTV cameras to record activities in the centre. The security system is being upgraded to include the use of facial recognition to identify, track the movements of and record individuals. So your answer is going to need to focus on facial recognition over already existing CCTV. So it's not asking you about CCTV. CCTV is already there. It's upgrading to include facial recognition. Okay, so focus on facial recognition over already existing CCTV. So we're going to talk about privacy. People won't like it or might not like it. So they're going to need to put signs up. Okay, whenever you go anywhere with CCTV, there's usually a sign saying CCTV. Same thing here, they'll need to say there's facial recognition in operation. That might mean, you know, known criminals might turn around and go somewhere else. People that are more private might turn around and go somewhere else. I'm assuming you probably can't wear a balaclava inside a shopping centre. We'll also need to talk about ethical issues. So people being tracked. Okay, that's an ethical issue. Now you might talk about positives. It might actually keep people safe. We saw what happened in Australia recently. Some madman with a machete. But also may discourage shoppers as well. So try and talk positively and negatively about each point. And then legal issues. So what law are we going to refer to here? Probably it's about protecting people's data. So protecting people's data is the Data Protection Act. And the new version is 2018. Okay, so Data Protection Act 2018. What happens with the data? Okay. Is there some sort of consent as well? You know, by shopping in the centre, are you automatically giving consent? So that's the sort of thing I would do to try and answer that question. They would be some of the points I'd try and use. Okay, under an hour, pretty much 55 minutes. That's how I would go about last year's paper one. Hopefully, when you're revising and you're preparing for your paper one next week, you may find this useful, you may find this helpful. I'll also be dropping a video later this week on 2022's paper one as well.